the hands-on demos with Lua scripting in our CLI solution. Also, don't miss out that we will explain how you can easily, without any cost, try everything that we show in this demo yourself directly after the webinar. So you'll get a link there. We'll do some Q&A if there's any questions based on the demo before we move over to our thoughts on what can be improved with COVESA VSS, on which we hope to get some inputs and thoughts. So, first topic, why COVESA VSS? There are many touch points, I think, with making things more developer-centric and available and simplifying ways for developers, really. But the three main reasons why we work with VSS is the ability to access signal data comes with curating the VSS data so you can safeguard the proprietary data. It's important to us. Our platform is also very collaborative focused. So the ability to see the same information in projects when there are multiple parties is crucial for transparency and having not having the bug ping pong that can often occur if you don't see the same data. So VSS is crucial in that as well. Last one being compatibility.
I
don't know how to unmute other people, but maybe you know, Paul. Anyway, the scale and use software between different platforms and vehicles is also a really huge business potential with VSS as well, to work more efficiently, work smarter, and not harder. With that, I will hand over to Jan to introduce that.
Thank you. My name is Jan. I work as a tech lead here at RemotiveLabs. And I'll give you a very brief introduction to what we do. And the main focus of today would be on the demo. But just a quick run through of what's on the platform. So we'll start with our product Remotive Broker, which is how you connect to the vehicle and can collect the vehicle signals. The broker talks all the automotive protocols that you are have in the car, and it translates this into a more developer-friendly way of working. So you can connect your laptop to the broker, and you can access the signals, visualized signals. You can see them in the web, you can see them in the CLI, and you can also have a gRPC API. The broker runs on any hardware, so it runs Docker on Linux. We do provide reference implementation on Raspberry Pi, but we can also run on other hardware. The broker is also very useful for test rigs. You can drive the test rigs, you can write signals in order to simulate ECUs and create the test setup you want. The broker is accessible remotely, which means that you don't have to be next to your test rig, you don't have to be in the garage, you can actually access these things remotely. Finally, we have the cloud solution, and this is where you collaborate and share data. You can, of course, control who gets access to the data in the cloud. And here we also run Remotive Broker. And this allows us to, well, the things you have recorded in the vehicle or in test rigs, you can then replay those recordings in the cloud. So you can stream your data to external applications, and you can perform transformations. We have integrations with, for example, Prototype. So how does this relate to VSS? Well, in the car, you have your proprietary signals. The broker transforms those signals into VSS. And the way we do that is we can either take a very simple configuration file where we just take the signal name and just convert it to VSS name, or you write a Lua script where you can do whatever you want. You can combine signals, you can change the frequency of the signals, and yeah, do whatever you want. And this is the focus of the demo today. You can also do this both with live data and with recorded data. Now we're going to have a bit of role play here. So we have our prototyping engineer that will show you his UI in prototype. Yes. And we have the automotive engineer doing like the signal processing. So let's start. Okay. Hi everyone. My name is Johan, developer here at RemotiveLabs. So let's see. Let's see what I'm going to. Okay. Is this okay? Everyone can see my screen?
Yes.
Yes. So thank you. And I will just start off with a brief introduction to our cloud, because that's where Alex, our and super duper engineer, will take over later. So I will just briefly show you this. And as Colin said, everything that I show you here is available once you just sign up or try it out. So all of these recorded drive cycles are on. So there are more, and you can press this import button, and then you can import more to try out. I'll just close that, and it will still continue. And so these are recorded drive cycles. Signal databases, those are the signal databases connected to these drive cycles. Brokers running in the cloud. This personal broker will be started automatically later. And you manage, you can invite your collaborators, and everything that you see, they also see. So I will take this drive cycle, and I will just start this on our virtual broker. So this will take the drive cycle, upload it to the broker, and prepare it so I can play it as it was a running vehicle. Once that's done, I open it up in our broker application, and this is where I control it. I can start, stop, play, and hopefully it will work. Since it's a demo, you never know. Okay, here it comes. So you can see the start, stop, play. So I can start playing the recording, and then we can search for something perhaps interesting, steering angle, for example. So we can see a graph with that. We can also add a video if you recorded something when you did it, and we can also just add a map. So you just get a kind of some information on what's happening. I'm not sure how good this looks in the sharing. And below, you can see we have some Python samples that you can do. We have some Android samples. We have prototype, and we have the CLI. So you can just copy paste, and you can try to play around with this. And as I said, this is like the raw data coming out from the cloud. But me, as a prototyper, I need VSS data, of course. So to help me with that, I'm now leaving over to you, Alex.
Thank you, Johan. Did you invite me to the project so we can collaborate there?
Yes, of course I did.
Please, thank you very much, Johan. Okay, so my name is Alexander Fickov. I'm the CDO here, and now I'm going to show you a little more intense techie session. I hope you bear with me. So for starters, I'm just gonna go to my cheat sheet, so to say. And first of all, since I'm gonna use a CLI quite a lot, I'm gonna start by logging in with CLI. I do that right away here, and that's done. Close this window again. If I go to this starting page, which I had. We're now going to compare the two transformations, where the first contains raw data and expose everything as it is present in the DBC file. And then we're going to look at the second transformation, which is called configuration VSS. That only exposes VSS signal. We're going to describe how these transformations are produced. You will learn to add your own transformations. So first of all, just like let's observe what's available here. So I'm just using the same project as Johan handed over to me, and I'll go in here to see what's going on this night drive to Luftkastellet video recording. So I just hit play here as Johan did, and actually if we browse here again, what we see here is like we have a chassis bus, we have a vehicle bus, and everything from the DVC is available here. I'm going to go for a steering angle as well as Johan did. I'm just going to look at that. And we can see that actually it ranges from -1000 to 1000. And as soon as the driver rotates the steering wheel, we should see some activity here. Let's give it like a few more seconds and maybe something will happen here. That would have been a little fun. It's fairly a straight driving journey, but however, we have some indication that something is happening here. Okay, so let's now go back to the cloud again and look at the data from another point of view with another transformation. I'm going to now pick the configuration VSS and hit play again. Now remember, it's the same recording in terms of the binary data which was collected from the vehicle. When I go to add signal visualization now, ultimately I only see VSS signals. And we have the steering angle here again. Steering angle, however, it's named something differently. And so these are the two different transformations. And now let's go into the details and see what are the differences here, really. I'll go back again, and I'll actually, what I'll do now is like I go to the files view, and now I want to download the default view and see what's going on in there, actually, the one with remote data without the transformation. I can hit the download button here. However, I prefer to use the CLI because it makes their form really easier, and we do like to automate stuff. So I'm going to download the configuration and copy this line from down here. And I go back to my terminal and I add unzip default here. And then I do open the code. Just see what's in that folder. I think like it will be fairly what you guys probably expect. What we have here, for instance, yes, for sure, we do need the databases, which is in this case, it's DVC files with the two different buses available on this vehicle.
It's not following the shirt.
Yeah, we see a terminal. Great to be here. Okay, so what I did actually, what I did was to download the configuration from here using the CLI command. And then I just basically unzipped it. And then I want to look at the code, so I did all the defaults. So let's go here. And I was trying to explain that, yes, there are two DVC files here, as you would have expected, because we have two buses. And then if we look in our interfaces, which is our main configuration file, actually, what we can see here is like, we pair these buses with what we call a namespace. This file contains more information, such as which type it is. And if this would have been in a vehicle, it would have said CAN here. Now it says UDP because it's running in the cloud environment. You can also see that it will say, hey, there's a database here, scripted JSON. If we go in there, actually it's empty. And these are just placeholder. It will only also point out the script folder. I will go into the script and we see it's empty. So this is a hint that the other configuration will probably not look like this. Going forward, if I go back to the web view again, and now I want to download the other configuration, which is going to be the configuration VSS. I just do the same here again. I download that. And I do. Let's now look at what we have in here. In this configuration VSS, now we have like a little different story. Still, we have the same two CAN buses. And if we go into the interfaces, it looks exactly as it did before, with the exception actually that this is not visible to the end user, nor is this visible to the end user. As you saw in the second view, we were only able to select the signals. So these VSS signals are available here. So first of all, there's like a simple mapping, which just tells us, hey, you know, this signal, which is the speed signal, which resides on the vehicle bus, I want you to rename that for me. And I want to call it a vehicle speed, which is very straightforward. And we do this for longitude, latitude, and so forth in this list. We also have the script location. And if you go to the script location, it says in here, and then we will see, hey, there's a number of scripts here. And these scripts are now in the programming language Lua, which is like a very nifty little language for doing small things. It's for, maybe some of you have been using it before. Wireshark is using it, for instance. Okay, and now let's look at these scripts which I have answered. First of all, it will say, hey, this is the signal I want to make available. And to make that available, I need some input signals. And the input signal in this scenario is, okay, on the vehicle bus, I need this signal. Whenever that signal arrives, this callback will be emitted. And from this point, it's for me to produce whatever code I want to emit whatever signal I want. This is the simplest example of the signals we have at hand here. If I go a little more advanced, I'm going to look at this. This is an attempt to produce this VSS signal, which is the state of charge, battery state of charge. And in this scenario, what we can see here, to be able to produce this, we need a nominal full pack energy and nominal energy remaining from the vehicle bus on this vehicle. And as soon as that arrives, what I'm going to do is actually just divide the two values with each other and then multiply it by 100, because I want it to be presented as a percentage. So this is yet another example. So, and I know that I show you a lot of code, but I'll keep this so for a little while. If we go a little more advanced, what we can see here actually is that we don't return anything on the same callback. Instead, we return something on a timer. And this enables us to resample the signal on whatever frequency we desire. So as long as we implement the timer frequency here, the system will know, hey, you know, let me produce a callback to this script every 10 times in 10 hertz. And instead, we return the values from here. So this gives us to accumulate, resample, or whatever we want to do. This is your area, and you can play with this as you wish to. So now the question is, like, how do we make these scripts? And how do I get from the raw view to this transformed view? And I guess we need some user-friendly approach here. If we go back here and just look at the data, which was played some time ago, let's see. I'll go back to the playback and do the non-transformation, because now we want to take an untransformed view and actually to generate a new transformed signal. I hit play here again, and actually, if I then do the 129, and I just help then pick this steering angle again, we see them both rendered here. And actually, there's a tab down here which helps me with the CLI again. If I want to subscribe to these signals and just look at them in the terminal or anything like that, I can do that. And here we go. We have them plotted here, which might be like more or less like useful. I can also do like a little nifty thing. I can do it in plotting a little prettier, so to say, for you who love terminals, for us who love terminals. Here we are. So let's assume now that what I really want to do is, like, I want to generate a script, which is using these two signals as input. And then again, I can use the CLI to help me generate the template for that. I'll just copy that again, and I run it here. And when I see here now, it outputs the code which it generates for me. So obviously I want to save that somewhere. So it's my script. And then we will open my script. Here it is. my script. And as you see there, it helped me. It actually, the two signals which were selected are available. On top of that, the frame is also available, which they live in. I'm going to remove the frame for now because I'm not really interested into that. And then I'm going to do like just a little hacky things here. Just let's see how the live coding plays with me. Return value bytes. Let's return the value 10 and see what happens. And now I want to run my script off the bat as it is. I go back to WebView again, and it actually tells me, hey, if you want to subscribe with a script instead, which you have local in your computer, you can just try it out by doing this. Let me do that. That'll take here, and what I see here, okay, it returns 10. Maybe it wasn't a very big surprise, but it's a good thing, good starting point. Go back again to edit my script, and let's go a little more advanced. Left side that I do actually, I get the time stamp in there. Oops. Let's, what's going on here? Okay, that's fine. And let's run the script as it is now instead. And it looks like this, not very easy to observe. Export. And we see what do we get here. Well, that looks like mostly like white noise to me. And what we're really doing here is like we have a very high frequency and it's microseconds. So let me just divide that by some reasonable number. Like let's do this. And I go back here again. See, maybe let's see if I, now it's starting to resemble a side. I can see the y-axis ranges from 1 to -1. I want to amplify that a little. I'll go back again. I just multiply that by 500. And I'll run it again. And here we go from 500 to. And just to make it a little more fun, everything, I mean, let's just add on the real signal, which we were actually intending to do something clever with. I do this. However, this is the same speed line. I want the angle. So now we have like a little bananas that let me know what we produce now really isn't the vehicle speed. It's rather my bogus steering angle. I run the script as it is, so let's look at it again. And when someone touches the steering wheel, we should probably see some side overlay on that. Maybe we need to have some patience here to see that happen. But I think it will happen. There we go. Something goes travels up and down. Let's assume now that this is like a new one. He needs this signal. This is the signal he was looking for. So let me then create a new configuration for you, Johan, because you're long awaited the signal. And I just take the configuration I had from before, and I just copy that. And actually, my script, which resides in this, I'll just copy my new script into the modified configuration scripts, and then actually I'll also upload the configuration as it is to a new configuration. And we go back to the web view to see what did we really do. I refresh this view here now, and then there's a modified configuration. Let's have a look and see what we have in there. Is this made you looking forward for this second here? Yes, exactly what I wanted. We do play here, and we go ahead and browse the signals again. Again, we see a number of signals here. If I scroll all the way to the bottom, I see my focus steering angle. If I just start to look at that, actually, it would have been more fun. Let me redo that. If we do my focus, and I really do the real steering angle on top of that. Let's look at that. Both together. Well, other than be slightly more interesting, I would say. A little more creative. So it's now we're starting to see some wheel turns. Okay, but however, I mean, so the last thing I want to do now is like, I don't want to have steering angle 129 available for you because he just wants to work with my local steering angle. So I'm going to once again go back to my code and actually go into the, to here and do code modified configuration. And I'm going to go into interfaces.json and actually make it hide these other signals. Folks, here we go. And once again, I just upload this configuration again. I have my flag set to override, so it will just destroy the old configuration. And let's go back there with the web view and look what do we have here now. When I did modify the configuration again. And hopefully, all available signals for me now should only be in my focus steering angle, which means that we're hiding the DC, the rotor, and everything from the user. So that's it, folks, from the demo. And you know, I know that this was exactly what you were looking for. And so this gives you the opportunity to modify the signals and stream them into whatever environment you want to stream them into. It's important to highlight here that this configuration now can be moved to a real vehicle. So you get them either, Jan was pointing out before, you get them from the recording or you get them live from the vehicle. So you can really like, if the information is on the bus, you will get the signals emitted live as if they really exist there. Handing back.
Okay, thank you. So I'm just gonna try to share again. Share. So where am I? Can I? Okay. Yeah, thank you, Alex. So now we are back where I left, where Alex took over before. And I'm just going to reload this and hopefully we will see his modified configuration. And I'm just going to show a sample of how to consume these signals. And I'm going to use Protopie Connect. Protopie Connect. Unfortunately, my bogus signal wasn't exactly what my Protopie, my pies are expecting. So I'm actually not going to use that one. I'm going to use our VSS configuration that Alex showed you. So on the right here, you have this instrument cluster that we're going to try to get going. So we are actually going to start that with our configuration VSS. First, while that one is starting, I here have Protopie. So the disclaimer here is I am definitely not the Protopie guy, but we can see that all messages that are inspected are VSS messages. So you can see those here. So, I mean, regardless of what you plug this one into, if it's VSS, it's going to work. We also need Protopie Connect, because that's required by our Protopie Connect for each app. So that's what it will connect to. To feed data into Protopie. Okay, so here we are, and so you can see we have these signals that we showed you before. So you can basically just take whatever signals you want. I'm just going to start with one because it's kind of more fun. And I'm going to start playing. And instead of the CLI, but not instead of the CLI actually, but we're going to take the Protopie tab. So we can see here again, we have some samples. So I can actually start the Protopie Bridge app connected to the broker with this signal that I chose. So basically this means that, okay, connect to Protopie Connect and the broker, subscribe to the signal and feed all values into Protopie Connect. So I'll just copy this one and I will paste it in. here, and you can see basically that it connects to both of them. It also getting signals, so that's a good sign. And going back here, you can see that we now have speed in our PI. And then basically, you could manually add signals, or you can have this one to help you out. I can select all of these, but I'm just going to take like this one and this one. And then we use this, and then our sample will be updated. So I'll just copy and paste it in. And run it again. Looks good. And then we go back. And then it's I hope you can see that it's turning, because it's actually turning. But you can always see it, basically. So now, yeah, me as a prototyper is super happy with your work, Alex. And of the demo, over to Karin again.
Yes.
Then
Ready?
So, as we mentioned, you can try everything that you saw here in RemotiveCloud free plan that we have made available. So all you have to do is go to cloud.remotivelabs.com and then sign up. You will get access to the different recordings and the possibility to try everything out. Like here, I created my own organization. If you are not already a customer, then log into your customer account, but you create your own organization automatically when you sign up, and then everything is there. So do connect if you have some questions, and it will be interesting now to, I guess, hear any feedback or questions so far on the demo before we talk about what can be improved with VSS. Are there any questions? I don't see anything in the chat, right?
No, there's nothing in the chat.
Any comments or thoughts? What we just showed?
Yeah, just it's Achim speaking. Thanks for the very interesting presentation. I'm really impressed about the graphical HMI you're proposing. Just for my understanding, I understood a lot of examples for reading out and filtering data from the vehicle. Is there also a feature to push data to the canvas?
Yeah, so that's a very expected question, isn't it? So our product, we do write to the canvases as well. However, this demo is just for consuming, and for consuming, this setup is very nifty, easy. For writing, and we're going to bring this question later.
This is
actually the question we have.
Yeah, yes. So let us save it a little, and we go back and visit that. So thank you.
That's the community discussion. Yeah. And are there any other questions about the demo?
Just one question I have is sourcing the data sets. How do you get access? How do you have access for exposing that, sharing that? I mean, what's open? What's the method of actually doing the mapping and recording? We get a lot of questions about, do you have sampled VSS data, for example? We do in COVESA, and there's lots of reasons for OEMs not to share their data. So that's just wondering how you came about it, and then how you deal with the IP issues.
But it's a test vehicle that we had available that we did the recordings with. And
yes, so we have that. So we were able to obtain these recordings basically. Without but I mean, they're available for you as well. So go ahead and I know that OEMs, they do find their DVCs very private.
Thank you.
any other questions or thoughts so far? If there are none, I guess we switch to the next slide.
Okay, sure.
To you, yeah.
Okay, so here we actually want to talk about that question you raised earlier. And this is not necessarily a implement with VSS. It's more like how would you use this? If you have a tool that can read and write VSS, how would you use that? So this is the kind of discussion we would like to have. And I think, for example, one thing that we noticed and we got quite a lot of questions about is when it comes to actuators, how do you get the desired value versus actual value is one issue. Another issue is, of course, when you have the VSS actuator, how does that map to the frame? Because the frame might contain other signals as well. And then you, of course, have the frames are being sent with a certain frequency. What happens when you send what's the expectations of how the system should behave when you set the actuator? And another quite common issue actually is the case where you have the frame owner, the hardware is still connected in the car. What happens in that case when you have multiple ECUs emitting the same signals and frames? So this, I mean, we have some ideas how to address this, but we would like to sort of get the community involvement here and open up slots for suggestions and discussions. So let's start. Has anyone done writing VSS signals to the vehicle? Is that something someone has done in this group?
I have. This is Ulf at Ford. We have done it, not using your stuff, but you asked about writing VSS to Canvas to actuate. We have actuated different, a couple of different actuators for the vehicle. Absolutely.
Yeah.
Yeah, I would say we have demos as well from Bosch e-test side where we've written two kind of controllers that are responsible for seat adjustments and the likes. Similar questions arise actually to you, so I think the proposal for community discussion is great.
So I can just add also that we will actually present this demo of writing to actuators on a vehicle on the coming AMM. So you can see it there if you want to.
Sounds really interesting. So how, I mean, I don't know if you can comment on the how do you handle, for example, the desired and actual value, or how do you handle the mapping to frames, for example?
Yeah, well, the desired to actual value, we were using the VISS reference implementation in this solution, and there in that communication stack there is a buffer below the server which contains the latest value. And actually earlier we had a solution where both the desired and the actual value was available in that buffer, but that has changed. So today the desired value goes directly to the actuator, so to say, and it's not stored in any longer time, at least in any buffer. So the way to find out is to write to it with the desired value and then subscribe to that to the same signal and reading it out and see how and if it has changed. That's the solution today. In a coming service interface, I call VISS and VSS as a signal-oriented solutions. In a service-oriented interface, which I'm working on developing, trying to get support in developing within COVESA, it will be more intuitive and more explicit to actually access both the desired and the actual value for any client. So these are my comments right now.
Thanks. Go ahead.
Can also say a few words how we have experimented in the Eclipse COVESA project, where we have some like basic, we've had just of a Python CAN package, some possibilities to write data down to CAN, but that is like for demo case, because first of all, you have a challenge that maybe you just provide data for a few bytes or bits within that particular CAN frame, and someone else provides the others. The second part is that in real systems, it's not always so that you are allowed to directly write, because there's anyway some middleware that's going to handle that and the recurring part, and you need to communicate by some interface to that middleware. So practical in a demo case, like, but for a real case, we haven't yet done anything in COVESA Eclipse.
See. Yeah, I think
regarding the question about mapping the VSS signal to a frame, which is a very relevant question and needs, of course, to be solved. I think my view there is that that should at least not be visible, and that should be abstracted away from the client. So however it's solved, it should be solved below or by the server or any subsystem below the server in the vehicle, and any developer accessing these VSS signals should not really have to worry about it.
Yes. Yeah, I mean, we have some ideas also that how we want to do this, but I think it's interesting to sort of see the state that this is like seems to be a fairly new thing. I think it's my and I think we will have interesting discussions. I'm looking forward to see your presentation. Yeah.
Oh.
And mention something, any further input or comments, or if there is no further comments or something you want to add, Paul? Thank you.
Yes, so I encourage you all to come get involved in VSS with these topics and put your proposals forward. There's meetings every Tuesday. You can put an issue in GitHub, you can do a pull request. Definitely, if you have questions about any of this, clearly the RemotiveLabs stuff, ask RemotiveLabs, but anything about COVESA, please feel free to reach out to me. So that's all I have.
Thanks
Thank
for
you
having.
for joining us. Thank you for having us. Yes.
Thank you. Thank you very much. If nothing else, I'll close the meeting. Thank you.
Great demo. Thanks, RemotiveLabs.
Thank you, RemotiveLabs.
Thank you.
Thanks.